In this video, we're going to look at how to solve the key types of questions when it comes to solving logarithmic equations. For those who don't know me, my name is Chris Iannazzoni. I've been tutoring for about 2 years now, and I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. The first kind of question is one where you simply have to evaluate a purely numerical logarithm. My recommendation here is to start by converting to an equivalent exponential form. Once we have that, we just solve the exponential by equating coefficients. Remember, x was a stand-in for the logarithm, so solving for x solves that logarithm. Some equations can get a little bit more complicated. These are going to require the use of the logarithm laws. My recommendation here is to start by taking any coefficients out the front of the logarithm into the brackets as powers using the power law. From there, we can use the product law to combine these logarithms, since they are two logarithms that are separated by an addition. Once we've combined it down to just a single logarithm, all we do from here is convert to exponential form and then solve the exponential. You don't always have to convert to exponential. In this example here, we can start out by using the product law to combine the right-hand side logarithms. Now from here, you do have two different options. You could use the previous method, by which you just combine the logarithms further, which would require you to subtract the right-hand side logarithm and then convert to exponential form. But there is a different way. Because both logarithms on either side of the equation have the same base, we can now ignore the logarithm part altogether and just equate the brackets. This works the exact same way that equating exponents does, but it doesn't require you to go through the entire process of converting to an equivalent exponential first. One of the most complicated scenarios is when the variable that you're trying to solve for is trapped inside the base of a logarithm. Under these circumstances, I recommend converting the base of your logarithm. So let's focus on that right-hand side logarithm. Now, specifically, we're just going to focus on the logarithm itself. For now, we're going to ignore the fact that it has a coefficient of 16. So we're just going to convert the base of this logarithm. Now, you do have a bit of freedom when it comes to choosing what base you want to choose for the new logarithm, but my recommendation is to choose your base to be the same as the current brackets. So in this case, choosing a base of 5. The reason we want to choose a base of 5 is because that will allow us to cancel out one of the resulting logarithms on that right-hand side, making our entire equation much more simple. Okay, now we've converted that logarithm to an equivalent logarithm. We've gone from log x of 5 to 1 over log 5x. All we do from here is replace the original logarithm with this converted form. Just remember that there was an original 16 as a coefficient, so don't forget to include that as well. Now from here, it's just pure arithmetic. To start with, we're just going to multiply both sides by our denominator. That's going to give us log 5 of x all squared. And then all we're going to do from there is square root both sides to cancel out that square, giving us plus minus 4 on the right-hand side. And then finally, converting to exponential form is going to give us 5 to the power of plus minus 4, which you can convert to individual answers of 1 over 625 and 625. Possibly the hardest type of question when it comes to logarithms are the literal questions. These kinds of questions rely heavily on your ability to convert between exponential and logarithmic forms. In fact, my recommendation is to start off by doing exactly that. So our question is going to start off by converting those first two logarithms to their equivalent exponential forms. Having done that, we now have the opportunity to sub in those new versions of x and y into that third logarithm, thus getting it purely in terms of a and c. All we do here is simplify the insides of the brackets by using our index laws. And having done that, we have 1 power in the brackets, which we can take out the front of our logarithm by using the power law. And then finally, we can cancel out that logarithm because its base and brackets are identical. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.